Frida, who is training to use a radar system, detects an airplane flying at a constant speed and heading in a straight line to pass directly over her location. She sees the airplane at an angle of elevation of 15 degrees and notes that it is maintaining a constant altitude of 6,250 feet, 6,250 feet. A minute later, she sees that the airplane at an angle of elevation of 52 degrees. How far has the airplane traveled to the nearest foot? Determine and state the speed of the airplane to the nearest mile per hour. Okay, so I went ahead and I drew out the situation here. Honestly, this is probably half the battle, okay, in interpreting and trying to decode and analyze this question. So this is the situation. So the airplane starts off over here, which I'm going to use a different color. I'm going to use blue. So the airplane starts over here, and it's at a height of 6,250, which forms a right angle with the ground, with the horizon, okay? A minute later, it will end up over here, still maintaining the same altitude, so still 6,250. So these two altitudes here are going to be the same length and still going to be perpendicular. Notice that we have two right triangles here. One right triangle with an angle of 15 degrees and another right triangle with an angle of 52 degrees. What we're going to do is we're going to try to determine the distance that the plane has traveled in a single minute, which I have denoted as the value of x right here. This is the length, that's the length of the dotted line. How are we going to do that? Well, what we're going to do is we're going to find out what is the distance that the plane is away horizontally from the location after the 1 minute, and we're also going to determine the distance that the plane was when Frida first noticed the plane far away with an angle of elevation of 52 degrees. So there are two different lengths that we need to find. I am going to call this guy right here my x2. Actually, I want to call that my x1. And I'm going to call this my x2. So this answer here that I'm trying to look for, like the x, is going to be x1 minus x2 then. Okay? So how are we going to do this? So let's find out what is x1 first. So notice that the 6,250, not 56, the 6,250 is opposite of 15 degrees. And x1 is adjacent to the 15 degrees. So those two sides will form a tangent ratio. So I can say tangent of 15 degrees is equal to 6,250 over x1. I want to cross multiply both sides by x1. So I have x1 tangent of 15 is equal to 6,250. I want to divide both sides by tangent 15. So I have x1 is equal to 6,250 over tangent of 15. And from there, I can figure out what x1 is. So I'm going to punch this into the calculator. So make sure your calculator setting is in degree, third row, second option. 6,250 divided by tangent of 15. That will be 23,325. So 23,325. We have to round our answers here. Let's see, how far has a plane traveled to the nearest foot? So I want to keep this in feet. And actually, I want to round at the end. So I'm going to take like maybe two more decimal places, 0.32. Oops. And I want to do the same thing now to solve for x2. So to get x2, again, I'm going to use a tangent ratio. So tangent of 52 is equal to, once again, 6,250 over x2. I cross multiply both sides to bring x2 to the left. And I want to divide both sides by tan 52. So I get x2 is equal to 6250 over tan 52. So I'm going to enter this into my calculator. So 6250 divided by tangent of 52. And that is 4883.035. 4883.04 roughly, right? Because I rounded 2 decimal places for x1. Okay, so now that I've found out what is x1 minus x2, x is going to be x1 minus x2. So I'm going to take the answer that I had before and subtract it by 4883.04. So I'm going to take the answer I had before, which was 23,23325.32 minus the answer that I got from before, and that is 18,442 feet. The answer says, or the question says, to round to the nearest feet, right? Yes. And then it says determine and state the speed of the airplane to the nearest mile per hour. So this is the distance that the plane had traveled, right? So we're going to take this 18,442 feet, and we want to convert this into miles per hour. How many feet is there in a mile? You know, they really should have actually told you this within the problem itself. So I forget myself. So I want to just quickly Google this. So feet to miles. What is that conversion there? So, or actually miles to feet, I should say. I got it backwards there. Miles to feet. I think it's 5,280. I was about to say 60. Okay, so it's 5,280. Okay. So we're going to take 5,280 feet. For every 5,280 feet, there's 1 mile. And again, I want the feet to cancel, right? And I want miles to be at the end. That's why I'm going to be dividing by 5,280. And since this distance will have been for 1 minute, right? This is 1 minute. I'm going to convert minutes into hours. So I know that there are 60 minutes in 1 hour. And now look, what happens here? The minutes will cancel. The final answer that I end up will be in miles per hour, mph, right? So I want to take that answer that I got a moment ago, multiply by 60, and divide by 5,280. Okay, so let's take a look. So multiply by 60, divided by 5,280. And that will be 209.57. 209.57. And it says in the question, it says to round to the nearest mile per hour. So the answer is 209 miles, actually 210 miles per hour. That's the answer there. That's it.